Start recording. Okay, then we get to the transcript. So many buttons to push here. Okay, move the thing out of the way, hide the transcript. There, we're back. Hi, everybody. I'm actually ready to start now. Thanks for joining us in the second to last week of class. We were talking before everyone got here about the next formative assessment and had questions about what you're supposed to do for that. I had posted, or at least I thought I had posted, a Word document to help clarify the structure of what I'm asking, and then just realized it was a dead link, so I just posted that. So let me get my screen share going so I can show you what I'm talking about. It is on the homework page for next Tuesday. I have a FA6 Answers Starter Kit here. So that will help give some structure to what I'm asking you to do. My plan is to go over it in class using this document and then filling out the answers. So formative assessment number 6 here, I have it pulled up inside Icon. This is drilling the idea of linear models and how the model tells you what the slope of any predictor would be in the presence of an interaction term. So for each question, I'm asking you to use this as the model and then to describe the logic and the code that you would use to get whatever quantity that I'm asking for. So for instance here, the first one is asking for a predicted outcome for a case that has these values of the predictors. So you don't have to do centering on any of this. You can just plug the values in directly. So for instance, on the Word document that I had posted, the idea of how you would go about this process. So here's the equation. Based on which values you have, you would have to fill in the equation with those values in the right places. And the corresponding estimate statement to do that would have this as a structure, where you would fill in the same values that went into the equation into the estimate statement, or into the LINCOM statement if you prefer to do it this data way. And so then the next question is asking for a predicted slope for the predictor G, conditional on someone who has a score of 2 on the F predictor, and then an F slope conditional on G and H, and then the last question is an I slope conditional on all 3. So we're looking for how do you figure out how the model tells you what the slope is, and then how would you communicate that to SAS or Stata? And we're going to keep practicing on that this week, and this will be something that you get to do in your homework. Algebra sad face, like this much, just a little tiny bit, so it's not so bad. Does that help, Fayaz? And you're giving me a sad face too? No, this is powerful. This is a powerful thing to know how to do, to rearrange an equation to get what you want out of it. This is moderator analysis. You promise no math. Am I asking you to do any of this math by hand? Right? I'm asking you to figure out how to tell the program to do the math for you. But there is no math. There's only logic. And I guess algebra sort of, to me, is more logic than math.
So can I ask a question, Lisa?
Please.
So do you want these statements in SAS? Like, do you want me to?
Yeah, so the instructions were to write the equation for and then a statement for.
Okay. But then just put the statement there, not run it or anything.
No, because there's no data.
Yeah, exactly. Yeah, sorry.
Yeah, so you'll get to do the data part in homework 6.
Okay.
So this is designed as another repetition of this process. Okay, does that clarify what I'm asking for the next one? Okay, so this is due next Monday, so a week from now, and hopefully after this week you will be more practiced at this kind of thing. The other thing I wanted to do is go over homework 5, what the correct answers are briefly, because everyone got it done. Hooray, hooray. So I have one example pulled up here. So this homework was looking at what we would call hierarchical regression type models, where you add a one predictor and then you add another set of predictors and then another set of predictors, and you watch what happens to the R-square for the model as you add predictors. And adding predictors also changes the interpretation of each of the previous effects in the model. So we had the usual enter the estimate for the residual variance. And do you remember why I always ask this question first?
Because if we got our model right, then we could get the other stuff right. But
That's right.
if we don't have the right model, then we'd kind of be screwed from the start.
Yes, exactly. So if you get this right, you're home free. The estimate for the fixed intercept, if this is an empty model, that's the only thing in it, and the standard error for that. And so then these values propagate down below. In terms of the interpretation, if all you have in the model is a fixed intercept, then that fixed intercept is the sample mean. So if you don't know anything else about a person, your best guess for their outcome is going to be the sample mean of the variable. So the empty model is literally giving you back the descriptive summary statistics for the outcome, the sample mean, and the variance of the outcome. And so we have sample mean here referring to what the fixed intercept represents. The residual variance is the squared average deviation from the mean. So variance is in a squared metric. And it is from the mean of each individual because that's what the model for the means is giving you at this point. That's what the fixed effects are giving. It's just from the mean because the mean is how each person's score is being predicted. The standard error is the average distance of the sample mean from the population mean, unsquared. So standard deviation and standard error are unsquared metrics. Variance is the squared version of each. And so it would be standard deviation becomes variance and standard error becomes sampling variance of whatever the estimate is. So any questions on section 1 for those? No? All right. So then changing up the vocabulary a little bit, as you noted, the amount of outcome variance that is unrelated to motivation. So in step 2, you were asked to put in the fixed slope for motivation to kick ass in graduate school. So that then is controlled for by being in the model, and the residual variance describes the amount of variability that's left. It looks like in this example, motivation captured 11% of the variance as the R-square. The test statistic for that, for the model, is the same thing as the test statistic for that one slope at this point. So t-squared is f in this case. And the p-value would come from the same place, either t or f. The fixed intercept. So I helped a few people troubleshoot this. In practice here, why would my fixed intercept potentially be wrong, but everything else be right? When might that happen?
If we didn't recenter, I think this one was the quantitative and verbal scores.
This one is motivation, but you're absolutely right. So yes, the intercept is the expected outcome when your predictors are 0. So if that's wrong, your predictors are 0 in the wrong place. So I told you to center motivation at 4, such that the intercept becomes the predicted outcome for somebody with a motivation level of 4 rather than actual 0. So then we have whether or not the model accounted for significant variance. That is a test of that new slope. And it is the difference in performance for a 1 unit difference in motivation. So it's per x, per unit change in x. The standard error of the slope is how far off the sample version of the slope would be on average from the population slope. And then the direction of the slope, if the slope is positive, then that means that higher ratings go with higher motivation. If the p-value for the slope is less than alpha of 0.05, then that is significant. So 2 by 2 sort of decision matrix for that. So any questions on section 2? So then section 3 is adding simultaneously the effect of verbal GRE and quantitative GRE as 2 new predictors. So at this step then, the trick is that you can't just look at the significance of either slope in isolation to ascertain whether or not the 2 slopes when added together increase the model R square. So what do you have to do instead to get, say, where is it? Which question is it? I'm reading, trying to talk and read at the same time is not working out. How did you get the test for whether or not the two new things help the model? Do you remember?
We had to do that additional f-test thing.
Additional f-test thing, yes.
Yep, and found it in the example coding, so that's how I knew how to do it.
Yeah. So it's a joint hypothesis test provided by, it's either contrast in SAS, test in Stata. Test can also be used in some procedures of SPSS, and there's analogs of that in R, GLHT or else contest MD, depending on the package that you're using. And so the idea then is to test those two slopes simultaneously. If that joint test is significant, that means that they must have increased the model R square significantly. And so then we have the interpretations of all of the individual slopes. So each is the change in Y for a 1 unit change in X, controlling for the other predictors, and then the usual process of determining whether or not each is significant and whether or not it's significantly positive or negative. So anything on that you want to ask about or talk about more? Okay, last one here. So no one asked me any questions about this last one, and this is the first time ever. So the way that I had instructed you to set up dummy contrast variables for fear of statistics was to contrast little versus moderate and moderate versus severe. So the way that you would have created those variables would be 0, 1, 1, and then 0, 0, 1. If you did it that way, you didn't have to write any estimate statements to get any of the mean differences. If you did it in the way that I asked you to do it in homework 4 instead, where it would be 0, 1, 0, and then 0, 0, 1, you would have gotten little versus moderate and little versus severe. And then moderate versus severe would have been a linear combination. So either way, you can end up at the same place. I had folks confused by that in the past, but apparently this group figured it out because no one asked me, or you asked each other. I'm not sure which, but either way. So that was the catch. So the idea then of the lumping of the two slopes together to get the overall impact of fear group is the exact same contrast or test statement. In classical analysis of variance terms, that would be called the omnibus mean effective group when you lump those two slopes together. You phoned a friend. That's fine. I'm okay with you if you guys helping each other, so long as at the end of the day each of you can do it. That's the only catch, right? So it's the same process, but it would be referred to as a different way. So this is how you would test whether or not the two slopes that define the three groups work together as a set. What is the impact of group as the two slopes? So the f-test for that you get via contrast or test is the answer to that question. So, and then the corresponding differences. And for each of these, one way that you may have gotten this incorrect is to turn the ordering around. So if I have little versus moderate, the slope applies to the moderate group. So the slope would describe how much higher or lower the moderate group is relative to little. Likewise, if I have moderate versus severe, that slope then describes how severe differs from moderate. So order matters because the sign would be backwards if you phrased it the other way. So knowing who's higher was the tricky part for this. And the moral of the story is that fear of statistics is bad for you. That's how I simulated the data. The high fear group is the worst off. All right. Any questions on that last part?
Can I ask a question?
Sure.
It's about question 94. And so when we add two fixed slopes, it is going to reduce it's going to increase the variance accounted for?
Increase the variance accounted for, because variance accounted for is R square.
Yeah, I'm sorry. Yeah, when I'm phrasing it, Now I understand that it doesn't mean that it would increase the variance, but it would increase the variance accounted for. Yeah.
Yep, it would either decrease the variance or increase the variance accounted for. Because
But
residual
why would you
variance,
phrase it like that?
like this,
Yeah.
because it's another way of saying the same thing that you may come across when you read articles. How much variance did your model account for? And end your sentence in a preposition. It's fine. So I apologize if that was confusing, but that is a legit way of saying it.
No, absolutely. You're right. I've seen papers like that, but I just didn't read through the entire thing. Increase in variance, no, because we have more slopes, so it would decrease the variance. But yeah.
Yeah, the residual variance can technically increase if you add a slope, if that slope is really non-significant and doesn't offset the degrees of freedom. But the sums of squares residual that creates the residual variance would never increase. It would only be the same or higher or lower. Excuse me, saying that backwards. Yeah.
So to tack on to that, I got the correct answer, but I didn't think of it in the way you described it. I selected the answer I did because the number out in front of F there was positive, and so I was like, positive, increase, it went up. Is that a good way to think about it? Or
Which number in front of F?
so, for you, that would be 0.17.
0.17 is the R square for the model. This number would only have meaning relative to what it used to be. So in the previous stage, before adding in fear of statistics, the R square was 0.49. After adding it in, the R square is 0.66, and so 0.17 is is the difference, and it's phrased in this way. It's like how much more of the variance did you account for? So I think that your rationale is solid. Because really the only possible answers here would be non-significant or significant. Like in practice, the residual variance is not going to go up, except in very rare cases, like I said, where the effect is so tiny that it offsets the degrees of freedom. So yeah, that works.
Good.
Yeah.
I would say the only challenge that through this homework was, well, not only challenge, one of the challenges in the homework was, I guess, whenever I started to make other variables, and then if I got something wrong or I get that red mark, it's like, where the heck did I go wrong? So then I'd have to go back and just rerun everything else before, and then somehow another table would pop up. So I don't know where I went wrong, but eventually I got it there, and then I would get a table that had my answer. So
Cool. So you ran into problems in trying to create the new predictors? Is that what you're saying?
yeah, I think so. Like whenever I was generating new variables or whatnot and labeling them, maybe I didn't put maybe I put a V instead of verses on some of them or something like that, and had to go back and look at it and rerun. But overall, it worked out. So happy to be on this side of it.
Indeed. So yeah, Stata is not only do you have to spell it the same way each time, but it's case sensitive as well. So that's why a lot of the Stata code that you'll see like online that other people have is entirely lowercase, so that they don't have to remember if they capitalized the versus or not and that kind of thing. One common thing that I see people doing is when they make new predictors, if you put the same word on the left-hand side of the equals and on the right-hand side of the equals. So like if you said motivation equals motivation minus 4, that overwrites the column. And so then if you try to, oh no, I'm going to make a new variable, I'm going to call it motivation 4 equals motivation minus 4, well then you've subtracted 4 twice. So in that if you do something that screws up the original variable when you're trying to make a new one, just running your code from the top again, where you re-import it and start fresh, is the only solution.
Yeah, that's where I went wrong initially. I did motivation 4 and motivation minus 4, and I was like, it's not giving me what I want. So then I just changed the word, and I was like, how did that work? So,
it works. Yes. Perseverance, that's the take-home message here. I don't care if you get it right on the first try or if it's the 100th try, right? Getting there eventually is the goal. So, and we have only one more homework to do. Hooray! Yes, we're almost there. So, as you might imagine, the last homework is about interaction terms. So, do you want to talk about those? Get ready to
Really
do
quick,
that.
can you, sorry, can you explain again the relative to slopes groups for the last in section 4?
Yes.
For some reason, the right answer still seems backwards to me, and so I can't figure out why I can't figure that out.
So the way that I phrased these is the alternative group relative to the reference group. So like this phrasing right here would be like little fear versus moderate fear in my code, meaning that little is my baseline and the slope then tells me how moderate differs from little. So if we said it the other way, if it was how little differs from moderate, then the coefficient would have to be backwards for that to work. Because the slope is always the slope informs about the group that is the 1 in the contrast. The 0 is the baseline. Okay, does that help? Yeah, so alternative relative to reference. Okay, any other questions on homework before I shut this down?
Just curious in like how the weighting or scoring for the results section works out. Because I've tried to figure out what each one's worth, and I don't know.
So I decide how many points an assignment is going to be in total. And then I look at how many questions are in each section and the relative perceived difficulty. And then I divide it up. So I decided, for instance, in this one, I thought computation would be 8 of it and 7 of it would be interpretation. And then out of the number possible, so it calculates how many each question is worth. So the algorithm that scores this builds that into the computation. Let me see if I can show it to you. If it's buried inside there or if it's visible. I think it should be visible. So if you ever want to see what a web page looks like, you right click on it and say view source code, and then you can get to what's underneath the hood in writing this. And so it's at the very bottom that would say no, so there's a formula in here that's operating on it that's just showing the values that are being rendered, so it doesn't show it, but I could dig that up if you're interested. But yeah, each single question is worth just a tiny fraction of a point.
Do you have the embedded answers in the HTML code?
No.
Oh, no. I'm just kidding. Yeah.
No, so what happens is this is running on an Access database where there is one tab for what the answer should be, a separate table for what the responses are, and then this just goes through and says if response matches answer, turn it green and score 1. If it doesn't, turn it red and score -1. And so then this, at the end of it, it tallies everything up and then does the math on to work out the number of points. So yeah, this is an ASP thing that's generating the web page, which is a very, very old way of doing it, but I'm old and that's what I know how to do and it works. So it's kludgy, but it works. So I started doing these homeworks when I realized that it was no longer feasible to cap my classes at 12 people, which is what I used to do, so that I could give everyone personal attention and hand grade all of their work. And it became a question of how can I clone myself? And this was the solution that I came up with. That way students get individual immediate feedback, but I'm not the one standing over their shoulder giving it to them. So that's what I got. And hopefully these results sections are designed to give you a template of how one would talk about this in a paper so that you could take these and use them because results sections, as you might imagine, are entirely formulaic. I mean, literally the computer could have written the results section for you based on just the conditional logic of if this number is positive and if this value is less than 0.05, say this. Otherwise, say that kind of thing. So, anywho. How about some good news for a change? Can I make a deal with you guys? So yes, I have 2 deals to make, and no one's required to wear a costume. It's not that kind of game show. So my deals are with respect to course evaluations. So you would have received an email from the university, I think on Sunday morning, saying that course evaluations are open. And I can see inside icon what proportion of you have responded, but I can't see who has responded. So let me pull up where my classes are right now. Because I have a deal. There are 9 of you in this class. If at least 8 of you fill out a university evaluation, everybody gets a point extra credit. That's my first deal. Because I believe in representative samples. And having as many of you fill out course evaluations as possible is a way to ensure representation. Sorry, everything's still spinning here. Am I frozen? No? Okay. Yeah. There's like a lag with your movement where you're kind of like moving very slowly. A true anarchist test? What does that mean?
Yeah, like if we want to hold back the group by not filling out the survey, then it's like just creating chaos for no reason.
That's right. Only one of you can do that. But I don't know who's filled it out. So I was going to check on this. It's like spinning incessantly here. Last I looked, I think it was a couple of you. All right, I'm just going to shut this down because it's taking up too much bandwidth. Get rid of that. And I don't need this either. There we go. Getting back to something. So that's deal number 1. But I said I had 2 deals. So the university used to allow us to add our own custom questions to the evaluations, and they don't anymore. So I have put together a Qualtrics survey as a supplemental course evaluation, and tomorrow morning each of you is going to get an email inviting you to complete the survey. The survey is anonymous in the sense that the responses are not tied to your email address, but it does tell me which email addresses completed a survey. So if you complete the Qualtrics survey, I will give you individually another extra credit point. And I do that because I take these evaluations seriously, and just knowing that I hated this class or I love this class doesn't tell me anything in terms of how to make it better or how to make it more efficient or more useful. So I have questions that are much more specific about the aspects of the class that would be directly informative, and I really very much care what you have to say. 6242 in this current form is not planned to be offered again, but odds are good I may end up teaching 6243 intermediate statistics, and so everything that you would have to say about this course would immediately port over to that version if I end up teaching it. So I value your feedback, and because I recognize that it takes time to provide thoughtful feedback, I think it's fair to give you a point for it. So just to reiterate, 1 point if you fill out the Qualtrics survey, and 1 point if the whole class gives me at least 8 responses out of the 9 for the university survey. So 2 separate surveys, 2 separate deals. Okay. In terms of things to think about, I'm especially interested in your feedback about the course format. So, relative to other courses that have exams, for instance, I've chosen not to do that. Is that a good thing? Is that a bad thing? Relative to other ways of doing online formats, right? Us meeting in person and trying to pretend like this is a normal class is one way to approach it. If you have ideas for how things may have could be better, or just simple suggestions about, I wish you could have done this differently, I'm very much interested in your feedback and I value it. So I do continually make changes to my courses, even the ones that I teach repeatedly based on feedback. As an example, you know your formative assessments that you do? They used to be in-class closed note quizzes. So I'd start off the class with that. That is the feedback that I received. Everybody hated them. They were hating them, and some people were cheating, and people could see the other people were cheating, and I was just like, this is not working as a format. This is not working. So then I moved it to out of class, and then I moved it to ungraded based on feedback, and so that's just an example of one change that I've made over the course of the semester. So anyway, that's my deal. Any questions about my deal? No? Okay, do you like the deal? Willing to play? Yes. So everybody is doing fine. No one needs to worry about failing or even getting a B at this point, I think, so long as you finish your last homework. So but I do want to acknowledge the work that I'm asking you to do in providing thoughtful evaluations. So, all right. Changing topics then. Interaction terms. So back to lecture 6 and how the model tells you how to get simple slopes out of these things. So do you want to go back over some of this? Would that be good to review? Yeah, let's do that. It's Tuesday. That means it's been at least 5 days. So we're talking about, see if I can blow this up a little bit. This is slide 16 I'm starting on here. So we're talking about how in the presence of an interaction term, the effect of a single predictor variable is not just its single slope. It also has to factor in any interaction slopes that the predictor is involved with. So in this example, for instance, we had student GPA being predicted by parent attitudes about the importance of education, parent education level measured in years, and an interaction between the two. So this model says that the effect of attitudes is both a function of beta 1 and beta 3, because attitudes is in there. Likewise, the effect of education is a function of both beta 2 and beta 3, because it's in here too. So then the trick is trying to figure out how to interpret the main effect slopes, so the effect of the variable when it's all by itself, as well as how the interaction term then moderates each of those simple main effect slopes. So there's 3 steps to figuring this out. First is to identify all of the terms in the model that have the variable for which you want the slope. Then factor out that common variable, and the result that is left provides the ingredients for how you would write an estimate or Lincom statement to get the simple slope as a function of the moderator variable. So we started practicing with this. So we did, for instance, this right here. So how to get the effect of attitudes, for instance, go up to the equation and find all of the terms that have attitudes in them. All of them, but only them. So for instance, the main effect of education doesn't go in here because it doesn't have attitudes in it. Likewise, if we were going to get the effect of education, only the terms that have education in common would be involved. And then factoring it out is taking the common term, so attitudes in each of these, moving it outside as a multiplier, and then seeing what's left. So right here, the term in brackets, that is the slope of attitudes, according to this model. It's a linear combination of the main effect slope of attitudes and the interaction term that describes how that effect of attitudes varies as a function of education. So do you remember then the trick to interpreting these simple main effects? Like, what does beta 1 tell me in this case? How would I talk about that number? Any ideas?
As the unique effect of only attitude.
It is a unique effect of attitudes holding everything else constant, but there's one more conditionality that has to apply. It's the effect of attitudes for what kind of person?
The centered value for all of the categories.
The centered value for education as the
Oh, okay.
moderator. Yeah. So in this case, because attitudes interacts with education, the only time that the slope for attitudes would be just beta 1 is if the second term goes to 0. So that would happen in this context when education equals 12 years, which would knock out the contribution of beta 3, leaving just beta 1 as the slope of attitudes. Then likewise, in parallel, to go the other way, if I want to talk about the effect of education, beta 2 is the effect of education after controlling for all the other predictors, but for what kind of person? 3. Yes. When the second term drops, which happens when attitudes is equals 3. So from there, what the role of beta 3 is to describe what happens to the slope as a function of the moderator variable. So beta 3 in this first case says how much beta 1 changes per unit education. In the second case here, it's the opposite. Beta 3 describes how much beta 2 changes as a function of attitudes. And so then we had started playing with these values. Let's see, on this slide right here. And so we were filling in these as a group, and I think that was where we left off. Okay, questions so far? No, we're good? Okay, does the baby have any questions? I don't want to leave him out. Because I have a hypothesis that he came out early because the stuff we were doing was so cool that he wanted to see it firsthand.
I will say that he stays awake the whole time we're doing stats homework. So.
Yeah, we got a legit 10th member of the class here now. All right, so then this one is where we were at last time. So trying to figure out how the model tells us what the slope of attitudes is as the predictor, using education as the moderator. So the idea that how important attitudes is in predicting GPA in this example depends on how educated your parents are. That's the idea. So we can ask, what would the slope of attitudes be for somebody with a 10th grade education? And the ingredients to filling in this statement here are right here. The little linear combination that describes how the model tells us what the slope of attitude should be. So the trick to understanding what these statements do is to remember that when you type each of these words, like when you type intercept and when you type attitudes, those words refer to their estimated beta fixed slopes. So the words take on the value of that fixed effect as it is given by the model. The coefficients that you type in here then are the multipliers of those betas, the terms that go in parentheses. So for instance, if I want the attitude slope for somebody with education equals 10, that means that the only terms in my model here that would be on, so to speak, that would have a non-zero value, would be terms that have attitudes within them. So for that reason, the intercept is 0 and the main effect of education is 0 because neither of those terms has anything to do with the attitude slope. So of the terms that are left, attitude 1 here refers to the idea that at a minimum, the slope of attitudes is going to be the slope given by its simple main effect. At a minimum, we need a beta 1. The influence of the interaction term then is added by providing the value of the moderator variable at which you want the predictor slope. So if I want the slope of attitudes for somebody with a 10th grade education relative to a 12th grade education as my reference. 10th grade is 2 fewer, and so it's -2. So the -2 applies to the value of education for which you want the attitude slope. Likewise, if I wanted the attitude slope for somebody with 18 years of education, that's what the 6 gives me in this line. Okay, with me so far? Okay, now let's flip the story. Reviewer 2 doesn't think that the effect of attitudes is interesting. Reviewer 2 wants the effect of education. Okay, fine, Reviewer 2, this one's for you. So the education slope.
Can I take a stab at it?
Yes.
So intercept and attitude will both be zeroed.
Because
they're not a factor in this. We're worried about education overall.
Correct.
Our education in the model, we have it 1 time, so that'll be 1, or on, I guess you would say 2.
Yep, because we're referring to one of these beta 2s.
Correct.
That's where the 1 goes. Yep.
And for this one, since we have in the model, it's -3, and we're trying to get to +2, I would say +5 there. Right?
Not quite.
Or dang it. How about, so would you just, so I looked at it in a subtraction sense, so 5 - 3. So would you go opposite and just do 1? Or, -1 - 3. Oh man, Alex, you're a man amongst boys.
Yeah, so I was trying to give like the actual value of attitudes, not the centered value. But so I think what you were implying is like if it was attitudes equals 2, then that would get me to 5. So that may have just been a communication problem. But yeah, so if 3 is the anchor point and I want it for someone with 2, then -1 goes here. But the rest of it is spot on. Okay, anyone else feeling brave? Want to do the second one here? Attitude slope equals 5. Education slope if attitudes equals 5, excuse me. What goes here? Yeah, nothing, because ed isn't in there. What goes here? 1, because I need 1 beta 2 at a minimum. And what goes here? A 2, yes. Nailed it. So this is the logic that you'll get a chance to practice on your last formative assessment. Out of class, low stakes, ungraded, open notes formative assessment based on prior class feedback about hating tests.
Lisa, can I ask, just to make sure I'm totally tracking on this, can I ask a quick question about these? So because you're asking for the education slope, like on the last 2, that's why you refer to the education slope above. And then because you know, like the beta 2 goes along with the education value above in the, I don't know what to call it. Is it an equation? I'm kind of losing my mind here. But so when I look at beta 2, then I reference above in the like the GPA right here.
Mm-hmm.
And that's how I know, that's how I count, I guess, how many times. Like that's why there's a 1. That's what I'm trying to get at. Okay.
Mm-hmm. You need 1 beta 2 slope as part of your ingredients for this, at a minimum.
Okay.
And if I had asked you for what would the education slope be if attitudes equals 3, then all you would need is beta 2.
Right.
And that's
because that would be 0 or whatever, because that's where we're.
so the beta 2 that's given by the model is specific to the centering point for the moderator variable.
Okay.
But the model tells you what it would be for any value of the moderating variable.
Mm-hmm. Mm-hmm. Okay, great. Thank you.
Good. Other questions? All right, the next one, we can work on this together. Here's another example. This one is somewhat parallel to your homework, although I have a more specifically parallel example to do, but this is just sort of another logic exercise. Let's say that I am predicting some outcome, and here's my model. It's an outcome in older adults, and I am predicting it with age, centered at 85, gender, which is binary in this example of man versus woman, so 0 is men, 1 is women, and their interaction. So what goes in here that provides the linear combination that gets me to how the model would predict the age slope? So step 1, find all the terms that have age in it.
Beta 1 and beta 3, or B1, B3.
Yep, I need this. I'm going to put brackets around it. And I need a beta 3 because that has age involved. Is that it, or am I missing something?
That looks it to me.
You need,
But-
I think you need to add woman to after beta 3.
Yes, we do.
Ah,
Yep, because beta 3 is a moderator. It's like an operator. And so you have to tell it for what kind of person do you want the age slope. The for what kind of person part is, okay, which predictors interact with age? Which predictors have a different age slope as a function of their different values? And so, yeah, we need that. But now we have the right ingredients. So we can answer the question down here, how does the model give us the age slope for men? So the ingredients to that answer are right here. That's what we just found. So what goes here?
would that be 2? Or wait. B1, technically, okay, so this is where it would be kind of confusing for me because I do see the B1 there, and that's just one time in the equation. Oh, we're looking at our age slope anyway, so I guess it'll be 1.
It is 1 because age 85 refers to this beta 1.
Yeah.
We need one of them. Always need one. Might need more, but always need one. What goes here?
We're worried about men, so we could 0 that out.
0 is correct, but not for the reason you just said.
Okay, lucky guess.
Because there's no beta 2.
Dang, that's why. Because this variable refers to this beta 2 right here. Beta 2 is not in our ingredients because it has nothing to do with age. This is a very common mistake, is to want to put the value of the gender there. It doesn't go there. But it does go over here. Because it's for a man, and given my coding scheme, 0 is men in this case. And so it is this place for gender that we're giving a 0, the moderator. How about the last line here? What goes here? If I want the age slope for women. 1, because I have 1 beta 1. What goes here? This is still 0 because there's still no beta 2 involved. And what goes here? 1. Yep. So there's 3 things that I might want to know in this model about the effective age. This model says that the effective age varies between genders. So I might want to know, is there a significant slope for age in the men? is there a significant slope for age for the women? And are those two slopes different? Of those three things that I might want to know, any one model can only give me two, because the third is always a linear combination. So beta 1 is going to tell me the age slope for men specifically, and I will get a significance test for that. Beta 3 is going to tell me how the age slope for women differs from the age slope for men as the reference, and I will get a significance test for that. So I know if the slope is significant for men, I know if it's different for women. What I don't know is what the age slope is for women. But it is just beta 1 plus beta 3, and so that's what this line here would be used, is to fill in that missing piece, the linear combination. So then I can say, does age matter in men? Does it matter in women? And does it matter more in women than men? Now, what if I added a third category? What if I added a non-binary condition, for instance? Could I do that? If I collected the data that way, could I do that? And I'm frozen. Oh, we're back. Are we back? Okay, my internet connection is unstable. Here we go. Okay, so if I collected the data where the response choices were, do you identify as a man, a woman, or non-binary, right? Let's say that we collected the data that way. What would I have to do to allow this model to change to adopt that third category?
Do we go down a row, over a column, or is nope? All right.
Yeah. I need another variable that would distinguish a reference group from the other alternative group. So I would be, for instance, a variable in which 0 was still men, but 1 meant non-binary. And so then I would have to add another simple main effect for that new variable and another interaction term. And then I would have the model tell me, then the model would be able to tell me what is the age slope in the men group, and then how does the age slope differ in the women group from men, and then how does the age slope differ in the non-binary group from men. And then there's 3 possible differences and 3 age slopes, and the others that aren't directly given are linear combinations.
Does syntax matter? Like, should we put would B3 then, or beta 3 then become for gender nonconforming, and then the beta 4, then we start our conditions?
That's probably how I would do it, is to list all the main effects first and then the interaction terms. It is, I would say that it's up to you, but that is actually not true in all software programs. So I just learned, for instance, that in SAS and Stata, you can list the terms that you want in the model in the order in which you want them, and that's how they'll show up in your output. I tried to do this in R, and it reordered them. It insisted on having all the main effects first, followed by all the interaction terms. So long as you're internally consistent and you know what you've asked for, then the ordering doesn't really matter. But typically people would do it in some pattern that's consistent with how they're thinking about these effects. But the point that I wanted to make is that then the idea of, does the age slope differ by gender identity, is a 2-slope interaction term in that case. That's actually lecture 7 and example 7 that we are unlikely to get to, but I have videos for it. Is extending these models to those cases. And yes, I thank you, Jen, for being the substitute teacher if I get kicked out of my class again. I'm glad your classmates made that decision for you, that you've been nominated. The honorary TA, I guess. All right. Questions on this so far? No? What if we go the other way? So the way that we're talking about this right now is as age as the predictor we care about and gender as the moderator. But reviewer 3 is like, nuh-uh, I care about gender differences. And I think gender differences are different if you're younger versus older. Okay, I can do that. So how do I build that set of ingredients to examine gender differences? We'll go back to just the binary gender version right now. What goes here?
Beta 2.
Beta 2. At a minimum, we need this.
And ensuring that we have beta 3 with the woman at the end.
Beta 3 is right.
Dang it.
But then would we do the age one? Like the age is now the moderator like women was?
Exactly. It's backwards. Yep. We care about the effect of being a woman. We think that depends on how old you are. So now we've got ingredients to get the gendered slope. So what goes here if I want the gender difference for an 80-year-old? Got one vote for 0. 0 is correct because beta 1's not in here. Age by itself has nothing to do with the gender slope. What goes here? A 1, because I need 1 beta 2 at a minimum. And what goes here if I want it for an 80-year-old? Yeah, -5. And then last but not least, another 0. Another 1. And if I want it for a 90-year-old, yeah, 5. Very good. You got it. It's like the magic eye poster that I can't see. Once you see the sailboat, you can't not see the sailboat. We got the sailboat going here. This is good. But this latter circumstance here brings up the arbitrariness of these statements. So one way of looking at this interaction term is talking about age as the slope we care about and gender as the moderator. And based on the fact that gender is a binary variable in this example, there's only 2 possible age slopes. There's one for men and there's one for women, the end. But here, I'm talking about gender differences as a function of quantitative age. So why not age 79? Why not age 87? Why not age 97 and a half? So what is commonly done to describe the interaction with a quantitative moderator is to make a picture of what's called simple slopes, where you would have the slope for the variable you care about at -1 standard deviation of the predictor, the moderator, excuse me, at 0 of the moderator, and at +1 standard deviation. So you'd show like what is the gender difference for somebody who's low on age, middle on age, or high on age. Now that's fine and all good, but it doesn't directly address the question as to at what point does gender matter? Because interaction slopes like this are non-parallel lines. So at some point, the model predicts the predictor's slope to be positive. At some point, it predicts it to be 0, and at some point, it predicts it to be negative. So I want to describe to you how one might go about answering that question. This is something that I find very useful, but I never got taught. So I want to give you this, the idea of regions of significance. Let me back out of this here so we can make it big, because I don't have any more fun color things to fill in. So the idea of regions of significance is to find the boundaries on the moderator at which the predictor slope would be positive, 0, or negative. So this is a hack by taking the formula for the t that you get to test each slope against its standard error and inverting it to figure out at what at the t boundaries of 1.96, for instance, if we do infinite denominator degrees of freedom, what are the values of the slopes that correspond to the t's at those boundaries? So there is the things that we need to get to figure out this formula is there's an additional piece of information that you have to ask for. To plug into the formula to get this, we have to get the covariance between the betas. So this is something that you have to ask for separately. It's called an asymptotic covariance matrix. You can get it out of Stata Regress, and you can get it out of a procedure in SAS called mixed instead, and I have an example for how to do this. But the idea is to figure out at what points on the moderator does the slope turn on, become 0, and then turn back on in the other direction. So for example, let's say that I have a model fit where I have a calculator for this, by the way, in Excel, and I also have a macro that I wrote in SAS to do this, and I'm sure someone's figured out a way to do this in Stata as well. So let's say that we have these results here, that beta 2 for the simple main effect of gender was estimated at negative 0.53, and that result was significant. And given the way that this model is phrased, that holds for an 85-year-old specifically. So then I would need to know the standard error squared for that beta to plug into the formula, which I can get. And the interaction slope, let's say that it is minus 0.11, which is also significant. And I need to know its standard error squared. So the direction of these things, if the gender slope represents the difference of how women differ from men, at age 85, who is worse? Who has a lower outcome? So if men are the 0, women are the 1, what does the fact that this coefficient is negative tell me? Who's lower?
Is it women?
It is women. Because the coefficient describes how women as the alternative 1 group differ from men as the 0 reference group. So that's why the wording in homework 5 has to be the right way, is it because you're talking about a sign difference. So we can think of this as a disadvantage for women, like as an idea. So this coefficient holds at the centering point of age, which is 85. What happens to that disadvantage for women as age increases? The interaction term tells you what happens. So if I have a negative main effect paired with a negative interaction, which of the 4 kinds is this? More negative. So if we put that into the context of the example, the gender slope becomes more negative as age increases, which means that it is stronger or weaker? It's stronger. So this model says that women have a bigger disadvantage if they're older. The gender gap increases. So if you think of the idea of this main effect of gender, like gender gap would be a way to describe that people would relate to. Because you have to know which way it's coded and then know which way the sign is, and then that takes a while. So it's a gender gap that favors men. That's what I've got here. That gender gap grows, becomes more negative in older people. So we know that at age 85, the gender gap is significant. And we know that the gender gap increases by 0.11 per year of age. So in older people, it would probably still be significant. But what about at age 80? Would there still be a gender gap and a lower age at age 80? I don't know. So we can use regions of significance to figure out at what age the gender gap starts, so to speak, becoming significant. And by plugging these values into the calculator, these are the results. So one boundary for the moderator is at age 79.52. So at age 79.2, we have a significant slope that is significantly negative. It stays significantly negative above that point. If I go lower than 80, the slope is non-significantly negative, and it eventually becomes positive if I go down all the way to 60. So this model says that below age 60, the gender gap would actually be opposite, favoring women. Between 60 and 80, the gender gap is non-significant. And then after 80, the gender gap is significant, favoring men. So I think this is much more useful in thinking about, like, at what point does gender matter? Because each of the values of age that you could test the slope at is an arbitrary point, and this gives you a better sense of, in a given sample, what proportion of your sample would have a significant slope in one direction versus another. So I have an example of this that I can show you as well. All right, there, we made it. Words. So big picture, the idea of moderation, it depends. The effect of a predictor depends on other predictors. That's what we're talking about. So I'll show you the code by which to examine these sorts of things next time. And because this is your first exposure to this, I'm not going to do anything nasty like three-way interactions or four-way interactions. But my next class gets to do those today. Yes, but the principles are the same. If I have a two-way interaction, its job is to adjust the main effects. If I had a three-way interaction, its job is to adjust the underlying two-way interactions, which in turn adjust the main effects. And the same thing happens in higher order power. So chapter 2 on your reading list for this unit has examples of three and even a four-way interaction and how you would go about getting simple slopes and simple interaction terms to explain that. But we'll just do two-way for now. All right, any questions before we call it a day? Nope. All right, then it is garbage day, which means I say, let me know if you need anything, and I'll see you Thursday. So, thanks, guys. Take care. Enjoy the weather.